instead of just 2's. So A is going to be the coefficient matrix of this thing. So this is going to be a 3 by 3 would be A11, all the 1's, then row 2, and row 3. Okay, so that's going to be our coefficient matrix. As long as the determinant is not 0, then we will have exactly one solution. If the determinant is 0, you have to solve it a different way because it's either infinitely many or no solution. And here we go for x. Again, you don't take the coefficients of x, you replace with the constants. But then you do take the coefficients of both y and z. So there's y, and then the coefficients of z are going to be the 3's. 1, 3, 2, 3, 3, 3. And divide by the determinant of a. So, for y, we will have all of the a's in column 1. Don't take the coefficients of y, replace with the constants. And then do take the coefficients of z, divide by the determinant of a, and one more for z, take the coefficients of x, take the coefficients, that should be a 1, 2, of y, and then don't take the coefficients of z. Alright, so let's use Cramer's rule to solve the system. Alright, I'm going to set up matrix A first. I'm going to go ahead and just write the determinant and find it. I'm going to find the determinant using expansion. So I'm going to pick a row or a column. I don't have any zeros, but this row has 1's, which I like. Oops, no, I don't like that. Oh no! Okay, so I've picked a 4, a -1, and a 1. I'm either going to multiply it by +1 or -1, okay? The 4 is in a positive spot, so it's going to stay. I don't really need to write anything, right? The -1 is in a negative spot, and the +1 is in a positive spot. And then we need some 2 by 2 determinants. I think that would be bigger. And there's one over here. These are all being added together. All right, so if I ignore the column that 4 is in, okay, here's what's left. 2, 3, -2, 6. Okay, get rid of that because I'm going to shift it over to where the -1 is. And what's left will be 2, 3, 5, and 6. Get rid of that and shift it over to where the +1 is. And copy down what's left. 2, 2, 5, -2. Alright, so this one will be 4 times 12 plus 6. Okay, this is going to become just +1 times 2 times 6 minus 3 times 5, and then +1 times 2 times -2 is -4 minus 2 times 5. Alright, and then just to do some, I'll just do some simplifying. 12 plus 6 is 18. 12 minus 15 is -3. And -4 minus 12 is 14. 4 times 18 is 72. Minus 3 is 69. Minus 14 is 55. Okay, so that's going to be the denominator of our 3 pieces. Okay, and let's go. For x, I'm going to take the constants. I'm going to replace the coefficients of x with the constants, but I'm going to take the coefficients of y and the coefficients of b. And remember, this will be divided by the determinant of a, which we just said is 55. Because I did expansion here, maybe I'll do the shortcut for this one and just rewrite. I don't know if it's even sure about that. The other method. Okay, and we'll do some multiplying. I'm going to go left to right first. 12 times 2 times 6 is 144. Negative 1, so that was the first diagonal. Negative 1 times 3 is negative 3 times 22 is negative 66. So it's minus 66. And then 1 times 1 times negative 2. Okay. And then we subtract the diagonals going the other direction. And just be careful how you line up your numbers. Sometimes your diagonals don't line up correctly. That can screw up your multiplication. Your handwriting is as terrible as mine. Alright, negative 1 times 6. 12 times 3 times 2. That's going to be negative 72. And 1 times 2 times 22. So, 144 minus 66 is 78 minus 2 is 76. Somebody yell at me later if that's not right. Negative 6 minus 72 is negative 78, plus 44 is negative. This is going to become positive 34. I lost it. I think it's 34. 76 plus 34 is 110. Wait a minute, I lost my denominator, didn't I? So remember, this whole thing is over that 55. So 76 plus 34 over 55. There we go. It's going to give us 2 for x. Alright. Go ahead and set it up. Well, I'll set it up for you for y, and then you're going to solve it. Put it into Edpuzzle. So, do take coefficients of x. Don't take coefficients of y. Replace with the constants. And then do take the coefficients of z. Okay, and find the determinant of that, and then divide by 55. Okay, use whatever method you like, and go ahead and put that into the Edpuzzle. Alright, I will tell you the answer back in class if you like, and you will see your answer obviously in the Edpuzzle. For z, I'm not going to even set it up for you. You go ahead and set up z and solve it and put that into the Edpuzzle as well. Alright, I do want to show you one more thing, and that of course is calculator. So these aren't as nice to do in your calculator because the matrix changes every time. It's a little annoying to put each new matrix into the calculator, but I'll do one of them. Let's just confirm x. So I'm going to put this x numerator matrix in. Then we'll go over to matrix and then to edit. I'm going to make it a 3 by 3. And then put these values in 12, negative 1, 1, 1, 2, 3, and then 22, negative 2, and 6. Okay, and we can find the determinant. I'm going to quit because I need to go to the computation screen. Get matrix again and go over to the math menu. There's all kinds of things you can do to your matrices. And that first one is to find the determinant. So find the determinant of matrix A for me. Remember that it has to be square to find the determinant. And then we go, we did get the 110. So then we divided it by the determinant of A and got 2. Okay, so you can double check your determinants that way. Let's say you come up with something that 55 doesn't go into. I would probably check that on your calculator. All right. Okay, so another thing we can find with a determinant, this is kind of random, is find the area of a triangle. Okay, if you know the vertices in a coordinate plane, line up all the x values, line up the corresponding y values, and then have a column of 1s. Okay, you find the determinant of that. You multiply by 1/2. And this looks a little bit funky. I know area is not plus or minus. Okay, this is actually, you have to choose whether it's going to be plus or minus, because the determinant might come out to be negative, and we know that area is not negative. Okay, so we would have to take the opposite of whatever answer we get. But if it comes out to be positive, we just make it positive. So we just pick the area so that the area is positive. Okay, another way that we would usually write this is to put it in absolute values. Well, absolute values and determinant signs look exactly the same, so it would be super confusing to have absolute values around a determinant like this. Okay, so which is why I think they put this plus or minus here. But it's basically just you choose. So find the area of a triangle with the given coordinates. So the x values are 0, 4, and 2. The y coordinates are 0, 1, and 5. And then throw in a row of 1s, or sorry, column of 1s. Now, if we need to find the determinant of this thing, I'm going to use expansion by cofactors because of that top row. That top row is delightful in terms of determinants, okay? Because those first two are zeros, and we don't even have to do it. So I'm only looking at this last spot, and this 1, go ahead and put in the Edpuzzle. Is the 1 in a positive or a negative spot? Okay, it's in a positive spot, which means I would not be multiplying it by -1. I would just be multiplying it by 1. So far, this is just 1 times 1, except that I lost my plus or minus 1/2. And then let's just put this in brackets. So this is 1 times 1 times, and then remember, we take the determinant of the row and the column that's left. So if I ignore also the column that 1 is in, and copy over the 4 remaining entries, we have a 4, a 1, 2, and a 5, and then let's see. This is just 1, and the determinant of this matrix will be 20 minus 2 is 18. That's already positive, so I'm going to pick a positive to multiply it by, a positive 1/2. And that's going to come out to be 9. So whatever units we're in, the area of the triangle that has vertices at these 3 points would have an area of 9 square units. Okay. Another thing that kind of goes along with this, if your points on a triangle, normally you'd have a third one over here, if they're collinear, right, the area of a triangle would just be 0. Because you wouldn't actually have a triangle, it would just be a flat line. So you can find out whether points are collinear if you get an area of 0. Okay, so let's check out these 3 points. We're going to set up the same thing. Area equals, I'm going to choose plus or minus 1/2 of the determinant. Take your x coordinates, so 3, 0, 9. Y coordinates, -1, -3, and 3, and then have a column of 1s. Okay, I do kind of like expansion by cofactors better, so I'm going to go ahead and pick this row, but you can do it the other way if you like. Let's see, let's put it in big old brackets. I don't have to worry about the 0 spot. -3. -3 is in a positive spot, so you can think about multiplying it by +1, okay, because this is positive, negative, positive. And then multiply it by the determinant of what's left. We'll find that in a second. This 1 is in a negative spot, so I'm going to multiply my 1 by a -1, or we can just think of it as subtracting 1 times its matrix. Okay, so for the -3, let's ignore its column, okay, and take all the spots that are left. So we'll have 3, 1, 9, and 1. And for the 1, this spot, I'm going to ignore that column and take the spots that are left. So 3, -1, 9, and 3. All right, do some computations. determinants first. This one will be 3 minus 9. And this one will be 9 plus 9. 3 minus 9 is negative 6. Negative 6 times negative 3 is positive 18. This is going to become minus 18. And look at that, whether we pick positive or negative, that is going to come out to be 0. So because the area of that, well, suspected not triangle, right? The area came out to be 0. That means that those points are collinear. All right. That is it, I believe. Let's, yep, double check. Nice work.